A useful report analysis for your collection is to identify the data types that are present. The report can be used to identify which types of helper applications are needed to parse and display your files. The National Archives and Records Administration, NARA, has the challenge of archiving all of the federal agency websites at the end of an administration. A standard analysis they run is to identify the types of data formats published across the federal websites. The number of data types exceeds 4,000. Each federal website expects the public to be able to parse and display all of their hosted content. Which data types are present within your collection? What are the most common data types? A rule to check the data types within your collection can either assume that data type name has already been set, or can extract the data type from the file extension. Two rules have been developed that illustrate both approaches. The rules use lists to aggregate the number of files that have each data type. The rule test list data type.r is shown here. The rule is available at LifeLibZone Home RW More Rules Test List Data Type.r. The rule has an input parameter, $r call, which defines the collection that will be processed. A query is constructed to retrieve the data type name for every file in the collection. The contains policy function is used to check whether the list *typ.type already contains the data type. If the data type has not been seen before, it is added to the list. If the data type has been seen before, the number of files of that type is incremented. A formatted list of the data types that were found is printed to standard out. The rule test list data x.r is shown here. The rule is available at LifeLibZone Home RW More Rules Test List Data ext.r. The rule has an input parameter $r call, which defines the collection that will be processed. A query is constructed to retrieve the data name for every file in the collection. For each file, the data type is extracted from the extension using the policy function ext. The contains policy function is then used to check whether the list *typ.type already contains the data type. If the data type has not been seen before, it is added to the list. If the data type has been seen before, the number of files of that type is incremented. A formatted list of the data types that were found is printed to standard out. Both approaches were run on the same collection, rules. The results indicate that the data type name persistent state information attribute has not been set for each file. For the rule test list data x.r, 4 files were analyzed and 2 extensions were found. 1 file with extension IR, 3 files with extension R. For the rule test list data type.r, 4 files were analyzed, but only 1 generic type was found. All 4 files were thought of as generic files. Take 7 minutes and complete exercise 76. Run the 2 rules for identifying the data type of files in a collection. LifeLibZone Home RW More Rules Test List Data Type. LifeLibZone Home RW More Rules Test List Data ext.r. Please load a paragraph describing your result into the Lifetime Library in the subcollection class INLS 624 by the end of today's class. The Coastal Hazard Center at the University of North Carolina at Chapel Hill and the University of Notre Dame co-developed the ADCIRC fluid transport code to analyze storm surge. The Renaissance Computing Institute collaborates on the prediction of the impact of hurricanes on the East Coast by coupling the ADCIRC surge and wave model with atmospheric prediction models. The Coast Guard used the predictions for Hurricanes Irene, Isaac, and Sandy to identify high-risk areas. The model uses finite elements on a triangular mesh to model topography and bathymetry, ocean depth. For each hurricane, multiple versions of the analysis are run to track the different atmospheric prediction models, and the results are turned into probabilities for the storm surge. There is a large community of users, including federal agencies, FEMA for updates to coastal inundation maps, U.S. Army Corps of Engineers for hurricane protection system design, Nuclear Regulatory Commission to evaluate storm surge risk to coastal nuclear power plants, and the National Hurricane Center to guide storm response. One challenge is that the analyses are run by sites that may be affected by a hurricane. They might experience flooding, power outages, or strong winds that limit the ability of the researchers to make the model runs and distribute the results. A method was needed to ensure that the results could be disseminated no matter where the hurricane was located. One approach is to replicate model results to a location out of the path of the storm. A data grid provides the mechanisms to automate the replication process. The simulation codes are being continually updated by a large development community. This includes both ADCIRC and atmospheric prediction models. Since multiple models are run and compared for each hurricane, a significant amount of data management is needed to associate each result with the corresponding analysis. By organizing the results into collections, comparison across models can be done, and analysis routines can automate the creation of probability charts for storm surge across the models. A current development effort is to apply the discovery environment developed by the iPlant Collaborative to manage the execution of the multiple models. This provides a way to organize workflows that retrieve input data sets, execute the prediction models, and store the results appropriately in collections. Since the discovery environment is integrated with the iRODS data grid, the results can also be automatically distributed across participating sites and federal agencies. An example of using the discovery environment is shown here. The 5 areas on the slide show views for specifying input files, creating a workflow and executing an analysis, managing notifications about the execution, managing the output collection, and visualizing the results.